Hi there, folks, and welcome to an update on Iceland. Today is Friday, August 16th. It's about 10 a.m. Mountain Daylight Time. That'd make it about 4 p.m. over in Iceland. Thanks for joining me. I'm Geology Professor Shawn Willsey. There's a new Met Office update out today, so I thought I'd put together another update. The waiting game basically continues. I also have a little sketch I'll show you at the end of our little session here, but I wanted to review the latest data. Yeah, the waiting game continues. The earthquakes are continuing. Doesn't seem to be a huge acceleration in the number of earthquakes we're receiving, and inflation seems to be maybe slowing down just a little bit. So the system is primed, the pressure is building, and it's anyone's guess as to when this actually starts to erupt, if that's what's going to happen first. Could be in the next 5 minutes, could be in the next 5 days. Doubt it would be 5 weeks, but it could take that long. And so that's, of course, what we're all kind of waiting for, is to see exactly what transpires next on the Reykjanes Peninsula. But it's a gorgeous day, as you can see on the webcams, and the webcams at this point, with the system being pretty much primed and ready to go, this might be the best place to continue to check back and see if you can catch the beginning of the eruption. But it's a beautiful day right now. This is the camera looking from Grindavik, looking to the north towards Hagafelt here on the right, and Þorbjörn here, the hill on the left. Another view here from I guess this is Þorbjörn here, this hill, looking more or less to the north, maybe northeast, looking at the cone that was built on May 29th in that direction there. So these cameras, and maybe some others as well, would be the ones to catch anything if and when it happens. So let's go to the latest Met Office update that just came out today. Not a whole lot of new stuff here, but they have a nice graph I want to show you here in a second. So you can see here magma intrusions and the eruption could start at any time. This is the Icelandic version. They haven't got the English version up as of this video. Usually it takes a few hours, a little bit of lag time there. So yeah, about 60 to 90 earthquakes per day. That's a solar cycle. Yeah, inflation going on, and pretty much just, I think, making everyone aware that it could happen at any point and to more or less be vigilant. There's an interesting part here. Model calculations show that the volume of magma under Svartsengi is now estimated to be greater than before the last eruption that began on May 29th. So we actually have more magma stored in the subsurface based on our model estimates than what took place prior to the last eruption. Now, you can get more volume in these systems with earthquakes. Earthquakes can break rock and generate more space that the magma can then intrude and occupy. There's also, I think, a little bit to be said for the thermal effects as you continually bring in this new magma, heat up the surrounding rocks. As it gets hotter, it's able to behave a little bit more elastically, so it can deform, stretch a little bit more to the point where, without breaking, at least to some point, and that can give you a little bit more space as well. And that's actually a pattern we've seen with each of these recurrent eruptions since the December 18th eruption, is a little bit more volume in the system, more uplift in terms of our elevations over time. And so here's the graph they've put together, which is nice. Basically just taking our favorite GPS station, which seems to be mostly centered or as close to the center of uplift as possible, the Svartsengi GPS station, and just aggregated the whole thing since early November. So what you'll see here, we have 3 graphs. Of course, GPS data gives us 3-dimensional information, so the movement of the station in a north-south direction. So on this plot here, if it's moving upwards, as you can see, all these red lines are jumping upwards, that's movement to the north. On the middle plot here, this is our east-west component of motion, and so in this case, these values are dropping below 0, the reference line, so these would be moving to the west. So this station's moving northwest over time with each intrusion and with each eruption. And then the final plot here shows uplift, so vertical up-down motion. And you can see in this case, a positive or upward movement is up, and then a drop down is down. And so this nicely shows and the blue lines here are the 2 intrusions we had, one on November 10th, the other one on March 2nd. The vertical red lines are our eruptions, so December 18th, January 14th, February 8th, March 16th, and then over here at May 29th. And then the red dots in between just track the movement of this station, in this case vertically, uplift over time. So you can see that steady uplift, inflation, reaching some threshold, and then it drops down when the eruption occurs. And then it starts inflating again, rising, and then it drops down. In this case, it didn't drop much. This was a different eruption, though, because it erupted further to the south, so possibly might have been related to that. But you can see this sort of sawtooth pattern for each one. The interesting thing here is if you look at, if we take this zero line here, which is a little misleading, and I'll show you that here in a second, you can see since the November 10th intrusion, there's been about cumulatively a little over 800, maybe 820 millimeters of upward movement at this station, so nearly a meter. That's pretty impressive to have that much vertical movement over a 8-9 month span, whatever this is, at that location. I'll show you here why this is a little bit misleading. They're taking, dropping it back down to zero more or less after the November 10th eruption and not taking into account the movement prior to that. If we come over here to a different site and go to that station, the Svartsengi station, and pull up the data, and let's go ahead and open this and this is for the whole year, and we just go to that same, there's that same plot I just showed you, but notice this goes back further. This goes back to September, October, November, and here you can see a little bit more the characterization. So they're dropping the zero line down to when the movement began, but what they're sort of negating is that negative, or that 200 plus millimeters of movement downward, and then so since that time, yes, we've had 800 millimeters or more of upward movement, but with respect to the reference line, the datum here that they originally were using, it's more like 6 or 620, so a little bit different number there, just to kind of explain that a bit. So that's our Met Office update. Let's check out these earthquakes here. I'll talk briefly about this big one here near Badabunga on the Central Highlands, a 3.5. There was also almost a 2.9 here in North Iceland near Grimsey. Of course, remember, Iceland sits on a divergent plate boundary. It's very tectonically active, and so it seems like almost any place in Iceland is susceptible or likely susceptible to these magnitude 3 or so earthquakes. But let's zoom in a little bit here on the Grindavik area. Again, this is just the last 24 hours. We can add in the negative value earthquakes to show all the detected earthquakes that have been verified as being real earthquakes. And I guess what I'm seeing here is, I really think this concentration of earthquakes here, I think, is the place to kind of watch. There's a lot of earthquakes down here, but they're more disseminated over a region. There's a lot of these faults that come through here, and so I think that's likely what these are representing. So while magma right now seems to be the main cause of many of these earthquakes, at least we would assume so, I think it's this cluster here, which is pretty much right on the vent of the last eruption on May 29th. This is the one I think to keep track of. This is where I would, if I had to keep looking at earthquakes in a specific area and kind of focus my attention in one place, I think I would watch this area here, because it's tightly clustered in terms of space. We can see what they look like again over time here in a minute, but I think this is still likely to be the place of the eruption, the next eruption, and the place, I think these earthquakes are maybe the most telling and might be indicative of that magma, breaking through. Its plumbing system has partially maybe solidified, and I'll show you that with a cross section I drew here at the end. And so it's got to reestablish that pathway of least resistance. And so these tiny little earthquakes, these less than 1 magnitude earthquakes, are very likely related to that. If we just screen out anything above a 1, you can see there's just a couple, maybe like 5 or 6 there. None above a 2, so no use in screening those out. So fairly small in terms of magnitude, and again, we don't expect there to necessarily be large magnitude earthquakes as we go into this next eruption, because that pathway's been established. It won't take as much energy or breaking of rock, therefore not as large of a magnitude earthquake, in order to create and establish that pathway. If we look at the earthquakes here, this looks back over the past Right now it's looking at the past, I guess, 4 or 5 days since the 12th of August. Again, you can see this sort of widely scattered zone in here, but then the cluster here near the Sunnuksgigar crater series, I think that's the place to look at. So just to the east of Silingarfelt, northwest of Hagafelt, and of course east of the power plant in Blue Lagoon, which sit over here. But that's where my money would be on this next eruption taking place. I think these other earthquakes are interesting, but probably just noise. We have very weak rock in this area that's already been fractured and busted up by all the events that have transpired over the last year or so. And so those are just likely relieving some of the regional stress there. So I'm not looking at any of these earthquakes as indicators of the magma pathway. It's these right here that right now I think I would be most focused on. But until we actually see that vent open up, anything is possible, of course. Let's look back again. I've been doing this the last couple times, and it's kind of insightful and interesting. And what you might be able to pick out here, if we go back to, this is like early July, again, not a lot of earthquakes. Here we are up to July 14th. So this is going week by week, basically, the 15th to the 21st of July. And what you're starting to see now is the earthquake starting to pick up in this, specifically in this area I've been talking about, but also in a few other places as well, along this the grabens and these faults that have formed here. So we've talked about the earthquake frequency picking up over the last few weeks, but I also think you can definitely see this area where the vent is likely to open up and where the vents have been in the past, having the most earthquakes, at least week by week. So here we are, going into the end of July, early August. Again, this is the area I think that's most telling. Here we are, August 5th to August 11th. Yeah, it's just widely distributed down here to the south. But again, this tight clustering here, I think, is more likely the magma conduit. And then that takes us up till today. So pretty interesting, I think, that looking at the earthquakes over the past few weeks or months can be telling as well. If we turn to GPS data, I mentioned that it looks like inflation is slowing down a little bit. Let's see if we can see that with a couple of the graphs here. We'll start with the Svartsengi one. Of course, here's the May 29th eruption here. Everything drops back down as we move that magma from the subsurface to the surface. There was kind of a weird rebound effect here. And then eventually there was some down dropping initially, but then it turned around. Inflation started resuming as more magma was moving into the system. There were tiny little ebbs and flows, but overall a fairly nice linear pattern here, more or less. But if you look at these last few points here, it does look like things might be kind of flattening out a little bit. The inflation is still happening, but at a much slower rate than it was previously. If we just check out maybe one other plot, let's go over to Eldvarp and see if we can see the same sort of thing. Again, uplift going on. And then, yeah, these last few data points, you can argue it a lot of ways, big error bars, but it does suggest that possibly the inflation rate or the uplift rate is slowing down a little bit. If we look at ground deformation with the last InSAR data, so remember this is satellites going over the area, using radar basically and bouncing it off the ground, flying over it again some days later, doing the same thing, and then measuring the difference in elevation. So it's able to detect tiny, tiny differences in elevation. So this just, this is another tool in addition to GPS to help confirm the information. So this one here would be the first flight over would be satellite pass would be August 2nd, excuse me, and then going up to August 14th. So I guess 2 days ago. So there you can see sort of the center of uplift. Grindavik here. Remember our vents over here. So that's what's kind of interesting about this is the magma body, the storage zone is a couple of kilometers away from the vent. And so the classic model of, a magma body and a conduit that comes straight above the magma chamber to some surface volcanic vent, that does not work here. Otherwise we would have, lava erupting basically right in the Blue Lagoon and the power plant area. And thankfully that's not the case. So while the center of uplift is over here, our active vent, at least over the last few months, has been over in this area here. No sign at all that it's going to, even though it's closer distance-wise to the Eldvarp system, or maybe it's equidistant, who knows. There's no sign that it's moving in that direction. So InSAR data showing the uplift as well. News is kind of in Iceland is pointing towards everything we're talking about here, just letting people know it's ready to erupt any time. He does make a point here, and they're talking to Benedict Olfigsen, who works at the Met Office, that the last time, he says, if we look at the last event in May, 2 weeks went by before it erupted, and there may well be some waiting time again now. So while the system does seem primed, and it does seem like it could erupt literally at any moment, it could be a matter of days or weeks before we actually see something play out, which is important. And then finally, I mentioned that earthquake at Barabunga, and so just to kind of show you again where that is, this is more over, not in the Reykjanes Peninsula, but out here in central Iceland, underneath the big ice sheet here at Vatnajökull. And so this is a 3.5 earthquake that happened, I think, in the last 24 hours. And so, yeah, just before 3 a.m. today on the 16th. And so you can kind of see where that's located, a few little aftershocks there. But everything I'm seeing so far, does not look like it's magma related. It seems to probably be, maybe a tectonic quake. It looks like an earthquake with the typical aftershock series that you would see. We have no uplift data. It's a trickier one to measure because it's sitting on a glacier, which is prone to volume loss and gain. So it's harder to do the satellite thing because when the ice melts and the ice, when it moves up and down a little bit, that can inhibit your ability to use the InSAR data. But nothing so far that's telling that it is related to anything like that. So let me switch you over just to wrap up this update to my fun little diagram I do. It's been a while since I've drawn one of these, and it may look a lot like some of the other ones I've done, but this might help conceptually with any new folks watching the videos here, or anyone who's kind of forgotten things. So first of all, realize this is probably fantasy land. This is not definitively how it looks in the subsurface. So this is just a cross section from west to east, going across this region just to the north of Grindavik. So here's the Eldvorp crater system over here, which we know has had several hundred millimeters of uplift since November 10th. Of course, the Svartsengi station, the power plant area, the Blue Lagoon area, has had maybe upwards of 800 or more millimeters of uplift since all this began last fall. We've got the hill here, Silingarfelt, the vent for most of our eruptions that have taken place over the past 9 months or so, Sunnuksgígar. You can see some of the lava there, again, just schematically. And then just, probably, rather than drawing the typical blob down here for the magma chamber, which is not probably accurate, remember this magma is invading whatever spaces it can find. So if it can find contacts between old lava flows, rubbly zones with high porosity permeability in the rock, if it can move upwards vertically through old faults, or maybe adjacent to a dike system, any just pre-existing weaknesses in the rock. So this is not geometrically correct, but it does probably show you schematically what the magma storage zone might look like. I know a lot of times we just draw a big ball or blob down here, but in this particular, and that might be true for some magma bodies like underneath a Mount St. Helens or something, but in this case it's different. And then remember, where the magma's coming up beneath Svartsengi is not where it's erupting. It's actually found a pathway off to the east, and it's erupting a few kilometers away. There might be a small constriction in the system. I just put that in there as a possibility. And so every time the magma volume rushes through this and we get an eruption, and once the pressure starts to dissipate, we can start to get crystallization at the constriction point that inhibits the next eruptive phase until we get enough pressure to override that constriction. Again, I don't know if that's there. Could be, could not, who knows. In this pathway here, some of this magma that has not been maybe molten since the May 29th eruption possibly is turned into what we call crystalline mush. Basically, it's crystals with a tiny bit of magma in between the crystals, so it's not really eruptible magma. But as we get closer and closer, as the days go by currently, more of that is probably getting heated, the pressure's rising and it's turning into melt. And what these earthquakes that have been happening under Sunnuksgigar might be are the magma slowly pushing its way and just breaking up this crystalline mush just a little bit. Again, not producing a big earthquake, but these tiny little 0.3, 0.5, even the negative magnitude earthquakes might be just small little incremental movements of the magma through the system, through the pathway, as it just kind of breaks up this more crystalline material and turns it more into melt, into eruptible magma. And that's what we don't know, is how much of the magma or the crystalline mush in this system, what percentage of it is actually crystals, what percentage of it is actually melt or magma. So again, just something to think about there. But remember that a lot of these rocks have been laid down with mainly a horizontal orientation to them. Lava flows, hyaloclastite from subglacial eruptions, pillow lavas. There's occasionally vertical structures with faults and dikes. But mainly we might see, so really what I think a lot of this looks like is a lot of horizontal and vertical lines that would represent the pathways, the easy pathways for the magma to work through. So I try to incorporate that a little bit into it here. So so maybe this, I have no doubts this is 100% a lie, but I think it's probably a decent conceptual model to think about when you're figuring out what might be going on there. That magma is 5 kilometers down or so. It's being fed by a deeper source and a larger reservoir, and it's got to work its way through this pathway, this maze, if you will, some of which include these dead ends, these arrested dikes, and it's got to find its way through that pathway that it's already established. It's already done the hard work. Back in November and leading up to the December eruption, it did the hard work of breaking the rock, generating the bigger earthquakes to make a vent at the surface. And now it's just got to reoccupy that vent, clear out some of that stagnated, partially crystallized magma, bring in that fresh supply, and then we'll see an eruption take place potentially. So hopefully this was helpful, and we'll see what goes on moving forward. I'll be back in the saddle over the weekend if anything takes place. Otherwise, just kind of look for another update. When the Met Office puts out a new update and I feel like there's something to share, that's when I kind of jump on and do these things. There's not like a schedule or rhyme or reason to them. But of course, if anything takes place, I'll try to jump on as quickly as I can and provide you with any information that I can, provide you with my analysis as I can see things with the webcams. Hopefully we can partner with our friends at NatureEye, get the drone up, and also watch some of the eruption dynamics take place in real time with the drone and maybe live stream some of that. So we'll see how things go. I do have school starting this next week, so that will limit my availability a bit, but I'll do the best I can in addition to putting out some of the other content and videos I have. So hopefully this was helpful and you enjoyed it. Thank you for your support of the channel, and appreciate all you do to support our geology learning community. Take care and have a good one.